Hello, thank you for watching this video. So in this video we're doing question 9 of November 2023 question paper mathematics paper 2. And the topic is proportionality, as you can see over here. So let's go. Or maybe with similarity, I think. So they are saying in the diagram ABCD is a parallelogram with AB equal to 14 units. AD is extended to E such that the ratio of AD to DE is 4:3. EB intersects DC at F and EB is equal to 21 units. No problem. So they are saying ABCD is a parallelogram. You can say ABCD is a parallelogram, right? And they are saying AB is equal to 14 units. AB is this length over here. This one side of the parallelogram, and it's equal to 14 units. No problem. They want to say that your AD is extended to E such that the ratio of AD to DE is equal to 4:3. So they are saying this length AD is extended to DE such that the ratio of AD is to DE is equal to 4:3. So, and also they went on, I'll come back to this, and they want to say that EB is equal to 21 units. EB is equal to 21 units. So what is EB? EB is this length over here. It's equal to 21 units. So let me write it down. The length from here to there to be here is 21 units. Not a problem. So let's come back to this. They're saying AD is reduced to E. So AD is reduced to E, so that the ratio of AD to DE is equal to 4:3, which means the ratio of this side to this side is 4:3. What does this mean? It means that, so this means that AD is to DE equal to 4:3. What does it mean? It means that your AD divided by DE is equal to 4/3, which is the ratio of AD to DE is equal to 4/3. So here's our ratio, here is 4/3. No problem. Now, the question becomes, does this mean AD is equal to 4? Not necessarily, not in general. It does not mean this is AD, this length is equal to 4. Does this mean DE is equal to 3? Not necessarily. It does not mean DE is equal to 3. Yes, it can be equal to 3, but it's not equal to 3. Don't think of it as equal to 3 unless you are told otherwise. So if you can say this is 4 units and you can say this is 3 units, so how can we do this? What is this really? So you can think of it as this, let's say as 4A over 3A, right? Where your A, let's say your A is a positive real number. So A is a number. So think of 4/3 as a simplified version of the length of those two. So you had AD, its length, let's say its length maybe was, I don't know what to say. Let's say maybe, what can you say? Let's say the length of AD was 8, maybe. This is an example. I'm not saying it's 8. Let's say the length of AD was equal to 8, right? And the length of DE was equal to 6. So if you say your AD over DE, it will be what? It will be 8, right? Over 6. And what does this simplify to? This will simplify to 4/3. So one thing about ratios, it's good to think of them as if they are simplified to the simplest form. So I'm not saying this was 8 and this was 6, but I'm just showing that because you see 4/3, just because the ratio is 4/3, it doesn't mean that the side is 4 and that side is 3. It could have been 8 and 6, but when you take the ratio of the two, which is this side over this side, it's simplified to the simplest ratio of that. So if now I'm saying, let's say I'm still continuing with this example that this was 8 and this was 4. So if you look at it, now this will be 4 times 2 here, and this will be 3 times 2. So you see these will cancel away, and then you're left with 4/3, which is what you have here. So when I'm saying the length of AD to DE is 4a/3a, that a is whatever number that was multiplying 4 before it was simplified to just 4/3. So this 2 is my a in that case. This 2 that you can see here and there is that a that you can see over there. It is that. So when I'm saying now 4a and 3a, I'm just using a as a general number, as a general real number for the real length of AD and that of DE. So that 4a now is my length depending on the value of a. So I'm going to clean my example now. So in my case, what I'm going to say, okay, if I have 4/3, I'll say, okay, it was 4 times something and 3 times something before it simplifies. If it was always like this, that something would be 1. If the length is 4 and the other one is 3, then which means our a is equal to 1. So we're not wrong. So I'll take my length of my AD to be 4a here, right? And that of DE to be 3a. So the entire length of this thing is equal to 7a over here, because it's 3a and 4a, which will add up to 7a. So that's how I look at ratios. So I'm going to do the first question, which is 9.1. What are they saying at 9.1? At 9.1, they are saying calculate with reasons the length of FB. So they want us to calculate the length of FB. What is FB? FB is this length over here. This length over here, from there to there. So they want us to find the length of FB. No problem. What do we do? So if you see this, you can see that you have some sort of triangle EAB and triangle EDF, right? EAB and EDF. So you have these two triangles, this small triangle over here and the big triangle over there, right? And what you need to know is that you can see that because ABCD is a parallelogram, this length over here is parallel to this one, which is your DC is parallel to your AB, right? So you have some sort of a proportionality theorem. I've been teaching proportionality theorem on other videos, but what this states is that if you have a triangle, right, like this, and you have a line joining two sides of your triangle, such that this line of yours is parallel to the third side, right? Then this line will divide your two sides proportionally. So if I'm saying this is A, B, C, D, E. So you have your triangle ABC, right? And your triangle ABC is divided by a line DE, such that that line of yours is parallel to the third side. They're saying that line segment DE will divide your triangle proportionally. What does that mean? If your DE divides your, sorry, not just triangle, it divides your sides proportionally. It means that the ratio, your AD, if you take your AD and divide it by BD, by DB, which is this length over this length, should be the same as AE over EC. That's what that means. Which means if you take the ratios of the same parts, those ratios should be equal. Because look here, I said the top part over the bottom part is equal to the top part there over the bottom part. Which is your AD is your top part, your DB is the bottom part. Look here, your AE is the top part and the EC is the top part. That's your proportionality theorem. It does not only work in that way. As long as you take the ratios of the same parts, it will always work. For example, let's say I were to say, let's say AD, right? AD, and divided by AB, which is the entire side, which is AB. It should be the same as if I take my AE over the entire length of the side, which is AC. As long as you take the ratios of the same parts, your proportionality theorem will always work. Your proportionality theorem will always work. Because look now, I said AD over your entire AB, equal to AE over your entire AC. It was going to work even if you had said that your DB over the entire AB, it was going to equal EC over the entire AC. That's your proportionality theorem. So if you look here now, you have your triangle AEB and a line segment dividing your two sides of your triangle, right? It divides the two sides of your triangle, and this line DF is parallel to the third side. Then your DF divides the two sides of this triangle proportionally in the same way as this one, in a similar way as that one. Let me repeat. Look now, we have triangle EAB, and you have a line DF that divides your triangle, divides the two sides of the triangle, and that DF is parallel to the third side. Then your DF now will be dividing your two sides at the same ratios, which means if I say this ratio over this ratio should be the same as that ratio there over the other, over AD over DA is called EF over FB, right? No problem. So what do they want us to find? They want us to find FB, right? No problem. So which means on the ratios that we will have to do here, they will have to include FB, right? Also, here we're given the entire length EB. So which means we should also use FB, which is this FB, on our ratios to show FB and this entire length here. Which means if I were to do this, I'll say, okay, this is my what? It will be my FB, which is what I'm trying to find. What am I given? I'm given EB, the entire length. EB is 21 over EB here. Is equal to what? Is equal to, so I took the lower part, I divided by the entire thing. So which on the other side, I have to take the lower part, which is DA, over the entire thing, EA. And then I have to explain that this is a proportionality theorem. Why did we use it? Because DC is parallel to AB. Right? No problem. In that case, I'll just substitute. What is my FB? My FB is what I'm trying to find. FB. What is my EB? My EB is 21, right? Over 21 is equal to DA. What is our DA? Our DA is 4A over EA. And our EA is the entire length here, which is 4A and 3A, which makes 7A over 7A. So this and that will go away. So what you have your FB over 21 is equal to 4 over 7. Right? Which is if you cross multiply, you find that your FB is equal to 21 times 4 over 7. Right? Therefore, your FB is the answer to that. So 3 times that, it looks like it's going to be 12 units. Because 3, yeah, it looks like it's going to be 12 units. Let me just double check. 21 times 4 over 7. Yeah, it is 12 units. So our FB is equal to 12. So this length from here to there, it is 12 units. Okay, so now we're doing 9.2. At 9.2, they're saying, prove with reason that triangle EDF is similar to triangle EAB. So they want us to prove that triangle EDF is similar to triangle EAB. So what does it mean for triangles to be similar? So if you're saying two triangles are similar, you're saying they are scaled versions of each other, which means they look identical to each other. It's either they look identical to each other, or one, they look like each other, but one is a bigger version of the other, if that makes sense. That's what I'm trying to say. So if they're identical, we call them congruent. They are also similar as well, right? Which is their scaled version of each other, and the scale factor is 1. But if you see this triangle here, if that's in this triangle and the bigger triangle are similar, which means this one, the small one, has been multiplied by a certain factor, by a certain number, so that it is big this size. Let's say this length here is is 2, which means if this one is 2 and whatever the other is, then if you multiply this side by, if they multiply this length by 2, it will become 4, which means this one will be a double of the other triangle. Or this one is a double of the other triangle. I'm not saying it is in this case, but I'm just making an example. So what I'm trying to say is that if you're saying two triangles are similar, they are scale division of each other. They're identical, or one looks like the other but it's bigger. How are they? How do you decide that they are similar? One, if the angles are identical, if they have exactly the same angles, then those two triangles are similar. Which is this angle for the bigger triangle is the same as this angle for this smaller triangle. This angle for the on this triangle, you should be able to, it should be this one here, and that angle over there, it should be that one over there. Then those two triangles are similar. Another way, if when you take the ratios of the corresponding sides, the ratios are equal, then those two triangles are similar. Let me make an example here on the side and say, okay, let's say we have triangle A, B, C, right? We have triangle A, B, C, and triangle D, E, F. If you are saying to me triangle A, B, C is similar to triangle D, E, F, what I learned, you are saying to me this angle is the same as that angle, which is angle A is equal to angle D. What else? Angle B is equal to angle E. And angle C is equal to angle F. Which is this, this is this, this is that, this is that. In that order exactly. Which is this angle here is this one over here. And this one here is this one over there. And this one here is that one over there. That's what you're saying. In this exact same order. And in a similar way, your AB here is your DE here, which is your AB. No, it's not. Sorry. Which means your AB here is represented by DE, which is corresponding to DE. Which is your AB, after it has been transformed, it will become your DE on that case. And your BC will become your EF in this case, and your AC will become your DF in that case. You can also see it here, because look, your AB here corresponds to DE, which is your AB corresponds to DE, and your BC corresponds to your EF, which is your BC corresponds to your EF, and your AC corresponds to your DF, which is your AC corresponds to DF, which is what you see. But because this one, this is, if this is angle A, this is small letter A, angle C is small letter C, small letter B. This is E, this is small letter E opposite, small letter F and small letter D. So to move from here to there, we multiplied all the sides by some K, which is a positive real number, right? So which means your E, to get E, that side DF corresponds to this BC, to AC, sorry. So which means you multiply B by K, so this is KB, and your D is equal to KA, and your F is equal to KC, right? No problem. So what you need to understand is that now, if you're saying these two triangles are similar, the ratios of the corresponding sides should be equal, which means if you take your DE, for example, let's say you take your DE and divide it by its corresponding side, because DE corresponds to AB divided by AB. It should be the same as what? It should be the same as your BC, your EF divided by BC, which should be the same as your DF divided by AC. And you'll find all of them are equal to K. All of them are equal to K because look, your DE over AB, where's your DE? Your DE is this one, is KC over AB, which is C. Your C and C will go away, so it's just equal to K. So, yeah, which means to prove that they are similar, is either you prove this condition that the corresponding angles are all equal, or the ratios of the corresponding sides of those triangles are equal. In this case, what do we have? We want to prove that these two triangles are what? Are similar. No problem. So, look now. Angle E. In triangle, what? These two triangles. Let's say in triangle EDF and triangle EAB. I'm looking at these two triangles. This angle E here, which is EDF, is in EDF, which is your angle F, your angle E here, which is your formed by DE and your EF, that angle, is equal to, which is your angle E, which is, I'll say D, EF, your angle E between DE and EF is equal to what? Is equal to AE. EB, which means this angle here, which is angle E on this triangle DEF, is equal to angle E on triangle AEB. So it's the same angle. It's equal. What is the reason? This is a common angle, this one. They are sharing that angle. It's a common angle. It's a common angle. Why? No problem. But look now. If this line is parallel to this one and that one, these are corresponding angles on parallel lines. Because I did teach on my batch action lessons. Go to my playlist and watch batch action lessons. There, I was teaching all sorts of angles, alternate angles, corresponding angles, and I did the proofs as well. Right? So these two, this angle and this angle here, are alternate angles on parallel lines. So this line is parallel to this one, so these two angles should be equal. So which means your angle F here for this triangle. So I'll say your angle F, which is angle F, is equal to this angle B there, which is say E B A. Why? These are corresponding angles on parallel lines. Why? Because our DC is parallel to AB. That's it. Also, I can say a similar thing and say this one over here is equal to this one, because they are also corresponding angles. But in honesty, I do not need to do that. If you manage to prove two corresponding angles are equal, that is enough. If you are able to show that this is equal to this in both triangles and these two are also equal, that's enough. You don't have to go to the third one. Showing those two conditions, it will be enough. Because if you're looking at two triangles and this angle for the small triangle is equal to this angle for the big triangle, and this angle here is equal to that angle for the small triangle is equal to that angle for the bigger triangle, then if you want this one, it will be 180 minus this plus this on the small one. Which is if you want this one, this angle here, it will be 180 minus this plus this. And on the big one, which is A, it will be 180 minus this and that. So it's the same thing. So why? So these two conditions, which is proving that this is equal to this, so this is equal to this, and this is equal to this, is enough. You could have said this is equal to this, or this is equal to or this is equal to this. It was going to be enough. Or you could have said this is equal to this because they are corresponding angles, and this is equal to this because they are corresponding angles. And that was going to do the work as well. You don't have to prove all three of them. Two will be enough. So in this case, I'm going to say therefore triangle what? Triangle EDF, right? EDF is similar to triangle what? It's similar to triangle EAB. It's similar to triangle EAB. Why? By angles. All angles. These two triangles have equal angles. These are equiangular triangles. So equiangular triangles are equal, which is triangles that have corresponding equal angles are similar. So we've proved this. There it is. Okay, so now we're doing 9.3. They're saying calculate with reasons the length of FC. So they want us to calculate the length of FC. What is FC? FC is this length from here to there. That's what they want us to find. FC. FC is from here to there. Doesn't look very nice. Ha! They want us to find FC, this length over here. How do we find FC? What do we know? We know that AB is equal to 14, so the entire length is equal to 14 as well, because you know opposite angles, opposite sides of a triangle, so the opposite sides of a parallelogram are equal. So we know that DC is equal to 14 as well, but we don't know its side. Okay, so how are we going to do this? What we just did, we just proved that this triangle, the smaller triangle EDF and EAB are similar, which means if you take the ratios of the corresponding sides, they are equal. I did explain there that if two triangles are similar and you take the ratios of the corresponding sides, those ratios will be equal. So what are we going to do? We'll say, okay, let's go to those triangles. We'll say in triangle EDF, in triangle EDF and triangle EAB. Right? In triangle EDF and triangle EAB, what do we have? We can say, okay, what do we have? We have this 12 here. We have the 21 over there, right? Fine. Also, what do we want? We want this, we have that. So look, we can say here, since we want this, right, we can say maybe AF, right, of this small triangle over EB of the bigger triangle should be the same as DF of the smaller triangle over AE over EAB of the bigger triangle. Why am I saying this? Because we said that these two triangles this is similar to that, right? You're saying this is similar to that, which means your EF here is on the small triangle, is EB on the bigger triangle, right? And your DF, which is the DF on the small triangle, is AB on the bigger triangle. No problem. So, because what I want to do, I want to have the DF here. I want to have this DF, and I want to have this AB. Because if I use DF, I'll need to have AB. And then I'll use EF here, and use the entire AB over there. So what I'll say, okay, if I say this EF and divide it by the entire length EB, it should be the same as DF over the entire AB. So what I'm saying is EF divided by EB, right? EF divided by EB is equal to DF divided by AB, right? I'll say these are corresponding ratios of what? Of similar triangles. These are corresponding ratios of similar triangles. That makes sense. So this is my EF over AB, EB, right, is equal to my DF over AB. So do I have EB, AF? No, I don't have the value of EF. Do I have EB? Yes, I do. It's 21. Do I have DF? My DF? No, it's what I'm looking. No, I'm not looking for. Yes, I'm looking for DF so that I know how much is this part. Then I'll be able to find AC. Fine, I don't have this as well. AB? Yes, I do have AB. But I can find EF, right? Because I know that EF on the diagram, this EF of yours plus what? Plus FB. If I add EF and FB, they give me the entire length, which is AB. And we were given EB is equal to 21. And we found that FB is equal to 12, right? So we have EF plus 12 is equal to 21, right? we get that EF plus EB is equal to 21. So what do we do? Just solve your EF. So 21 minus 12, you get that your EF is equal to 9 units. Fine. So what do we do at this point? So we get that this length over here is equal to 9 units. Fine. Which means on this formula, we have this now. We're only missing df, which is what we're trying to find anyway, because we're trying to find this length. Once we know what this length is, we'll be able to find fc, because we know that dc as a whole is equal to ab, because these are opposite sides of a parallelogram. Fine. So what do we do? So okay. In that case, let's go to this ratio. Our EF there, what is our EF? Our EF is 9 units divided by EB. What is your EB? EB is equal to 21. Is equal to DF, which is what we're trying to find, over AB, which is equal to 14. So we get that our DF is equal to 14 times 9 over 21, which is equal to the answer that you will get there. So let's punch that and see what you get. 14 times 9 over 21. So we get that this is equal to 6 units. So our DF is equal to 6 units. So which means this length over here is equal to 6. So we know that DC is equal to AB, because these are opposite sides of your parallelogram. So we say, okay, DC is equal to AB. Why? These are opposite sides of your parallelogram. Right? DC. What is DC made of? DC is equal to your DF plus your FC, which makes up AB, of course, because I've broken this down. What is your DF? Your DF is equal to 6 plus your FC, which is what we were asked to find. FC is equal to 14 AB, because we know AB is 14. Therefore, the FC is equal to 14 minus 6, which is about 8 units. So we get that our FC here is equal to 8 units. And I think that's how it is. I think that's how it is. And I'm done with question 9. And I hope it does make sense to you, as it does to me. So now we'll move to question 10, and we'll be done with this question paper. Thank you for watching.